Hello. Hello everyone. Lakshay, Priyanka, Akshay. Sound is fine? Good evening, Nishant. Right, thanks, Akshay. Hello, hi, good evening. Yes, thanks, Amulya. I've just started it beforehand so that there is no issue of sound or anything. Good evening, Tayal, Naman, Sagar, Ujjwal. Nice to see you all too. So before we start with today's session, which is our second in continuation, it's divisibility and remainders 2. So whatever you have learned yesterday, you can recall fast. Somehow I was not able to come yesterday, Rishikesh. Tanish, aapka bhi good evening. Yes, whatever you have discussed yesterday, you can please recap fast in the comments. I think you have learned about the divisibility rules. Ramu is asking 17, 19, 13 divisibility rule. Can you explain? Okay. Do we get remainders questions directly in exam? Yes, directly. The question will ask, what will be the remainder when this number is divided by this number? Direct questions are there. Sometimes questions are in the form of storyline also, but mostly questions based on remainders are direct. Find the remainder when this particular number is divided by this particular divisor. Akarshita, 1 se 9 tak, right? You revised about divisibility rules from the numbers 1 to 9. See, today we are going to cover a lot more things. So, a lot more information, a lot more new learnings are going to be there. So, you have to be very, very active. Okay, 1001, 100, 199 divisibility rules. Nice. ये आपने कल किया था. Okay, we shall revise that. Don't worry. What is the average number of questions which come from this topic? That's not a good question. That's not fixed. No, it depends on the examiner. Okay, Mayank, I have seen your comment. You want to recap? Negative remainder we are going to learn today. Prashant, we are going to discuss about that. How to calculate remainders, how remainder can be negative, how to convert from negative to positive and all. We'll discuss that in detail today. Don't worry. Please revise mode method once again. Mode is not a method. Mode is just a representation. So don't worry about it. If you see your normal calculators, there also you will find this mode function. In your Excel file, there you also find this mode function. So that is just a function which gives us remainder. That's it. So don't worry about the mode function or mode representation. If you are somehow confused about that, leave it. It's not very important. That's just a representation. I will discuss that. Yes, so I think about 400 students have joined so far, and others would be certainly joining. Mode method once again. Don't worry, it's not a method. We will discuss that. We'll cover that. Okay, so let's start. And in first 5-10 minutes, I think we can revise the things which you have done yesterday. हाँ, कल की क्लास का quick revision करते हैं राधा. That's perfectly fine. There are many questions. I missed the comment. Give us a date or 4 to give us a class. Don't worry. Okay, after today's class, you are going to have a gap of 1 day, I guess. So this is our last class in this week for quant. After that, we will have some classes for DI, LR, or bubble. So for quant, you are going to have a gap of 1 week. You will be having enough time to solve many questions. Okay, so let's start with our recap. And we have almost 500 students here. Okay. So in today's topic, we are going to discuss about the remainders, how to find remainders, and there are some properties regarding that. And Euler's number is first topic of that. But before starting this, I'm going to discuss the same thing again, which you had done yesterday. Quickly, let's recap. And don't put unnecessary comments so that is assignment second of divisibility and remainders based on today's class or yesterday's. That you can see very easily by seeing the questions. That's not a difficult part. We should be able to solve all the questions. What's the issue in that? See, you discussed divisibility rules yesterday. That was one part. ठीक है ना? And which rules you discussed? You discussed rule of 2 and all powers of 2, right? 2 power n. And same way, you discussed rule of 5 and all powers of 5. What was that? That was a common rule. And rule was that you need to check whether number formed by last n digits is divisible by the divisor or not, right? That was the basic rule. Okay? Is there any confusion in that? I think we have created a conceptual video also on that. I hope you have seen that, right? Okay. Sakshi will come to assignment questions later. If you will be able to cover today's part fast, I will do that. I will try to do that. So I wish to have some at least 15-20 minutes to solve your doubts. Okay, don't worry. Okay, there's no doubt in this. So you all are clear about this, right? So whether a number is divisible by 2 power n or 5 power n or not. So how do we solve it? So we just need to see that number formed by last n digits is divisible by that particular divisor or not, right? Is my sound clear? Everyone, please comment. Here I'm seeing one comment by, I think, Siddharth. He's saying no sound. Sound is okay? Is my sound audible? Are you able to hear properly? Clear. So those who are having any issue, please refresh. Please refresh. Okay, so this part is clear to everyone. So how to find remainder? Okay, next after that, you also discussed the divisibility rule of 3 and 9. All right. So they were both having same rule. What was the rule? That sum of the digits of the number must have been divisible by these divisors, right? See, yes, whoever is having problem in sound, please refresh. Anyway, so 3 or 9, they both are having same divisibility rule that sum of the digits of the number must be divisible by these particular divisors. See, what is important regarding these divisibility rules is that if the number is not divisible, then whatever remains is the remainder, which is our next topic basically. Okay, na? Okay, let's move further. So after this, you also covered divisibility rule for numbers of the form 99, basically 10 power n minus 1. Wait. It is 10 power n minus 1 and 10 power n plus 1. You also covered that, and that rule was not for 27. Yes, so 3-9 wala jo rule tha, that rule was not for 27. Now 27 will be covered in this third category. So 10 power n minus 1 and 10 power n plus 1. More concept was introduced. I heard that. So don't worry. I told you that is not a concept. We will cover that. Don't worry. So 10 power n minus 1 and 10 power n plus 1. You discussed that part also, no? All right, 999 and so on. Right, 99, 999, 9999 and so on. Similarly, 101 and 1001, 10,001 and so on. Yes, negative remainder bhi, bilkul. Okay, I'm telling this again. Many of you are having doubt in this. So that's not a very difficult task. It's very easy. First, let's check out for which numbers this rule is applicable. If I put here n is a natural number. If I put n equals to 1, let me make a table here. I think this would be visible to you. Yes, it will be visible to you. So let me write here n. I'm keeping the different values of n. Let me create some space. Okay, so here I'm writing n. Okay, so rule is common for both of these types of divisors. All divisors of 10 power n minus 1, whatever divisors are in this form, so their result is that whatever groups we are going to form, they are to be added. Is this color visible? Green, dark. Maybe let me change the color to light blue, or I'm taking light green. Okay, so whatever divisors are of this form, 10 power n minus 1, so they are to be added, the terms are to be added. And in this case, the terms are to be alternate, positive and negative. I will explain it again, although you have discussed this yesterday, but I'm again repeating it. So now, when n equals to 1, so in this first case, my divisor becomes 10 power n minus 1, that is 10 minus 1, that is 9. Right? The rule for 9 is that make a group of 1 digits at a time from the rightmost end, and all the groups are to be added. There's a basic rule for 9, जो कि आप यहाँ भी use करते हैं, right? Is it okay? I think there are a lot more unnecessary comments going on. Please, no unnecessary comments. So 10 power n minus 1. So if I put n equals to 1, so the divisor becomes 9. And now rule for 9 is that make a group of single digits and all the terms are to be added. As in the normally we write sum of the digits, right? And similarly, for n equals to 1, this divisor becomes 10 power 1 plus 1, that is 11. Now what is the rule? Rule is that make a group of single digit at a time, but the digits are to be alternate, positive, negative, positive, negative. Now this grouping we are starting from the rightmost end. Okay? So both 9 and 11, these rules you already knew. So they also fall into basically this category only. Now first, if I put n equals to 2, so this divisor becomes 10 square minus 1, that is 99. So rule for 99 is what? So we need to make a group of two digits at a time and add them all, right? So that's the basic way. You have solved some questions also based on this. And same way for 10 power n plus 1, if I put n equals to 2, that becomes 10 square plus 1, that is 101. So rule for 101 is also similar. Make group of two digits at a time, but this time the groups are going to be alternate, positive, negative, positive, negative, right? Yes, for 99 and 101. And very important point here is that these rules are not only for these particular divisors, but all their factors. I repeat, this rule is not only for this particular divisor, but all other factors. How is that? See, if a number is divisible by 99, tell me in the comments, will the number be divisible by 11 or not? I repeat, if a number is divisible by 99, so will the number be divisible by 11 or not? Yes. Why? Because if number is divisible by 99, so 11 is a factor. Of course, it is going to be divisible by 11, right? Okay, one more. If number is not divisible by 99, let's say number when divided by 99, it gives some remainder, suppose 7. Okay, I do not know what is the number, but this number when divided by 99 gives remainder 7. Can you tell me what will be the remainder when the same number is divided by 11? What will be the remainder when this same number is divided by 11? Please write in the comments. Yes, of course, 7. Because this 99k, whatever be the value of k, this term is divisible by 99. So it is divisible by 11 as well. So remainder will be obtained by the remaining term, that is 7, right? Suppose a number when divided by 99 gives remainder 17. That's also possible, no? A number when divided by 99 gives remainder 17. Now can you tell me, when this same number is divided by 11, what will be the remainder? When this same number is divided by 11. Now this remainder I have changed, it is 17 now. Aditi, that's a question only. Question says, let's say I'm writing it here, there is a number n which when divided by 99 gives remainder, I'm saying 17. Okay? So now question says, what will be the remainder when the same number is divided by 11? Tell me the answer. That's the question on your screen. Yes, perfect, fine. It's 6 only. Why? Because the number is of the form 99k plus 17. Now 99k is divisible by 11. So I just need to find the remainder of this 17 with 11. Right? So that's the way question is asked. Okay? Let's move further now. So basically point was that these rules are not only for these divisors only, but they're factors also. And that is the main purpose we are discussing about these rules. Let's continue. If I put n equals to 3, in that case, this divisor becomes 10 cube minus 1, which is 999. The rule is quite obvious that we need to make a group of 3 digits at a time, and all the groups are to be added together, right? Ujjwal says, please repeat this again, sir, the factor wala thing. Factor, bhai, maine sirf itna bola, I'm writing this number here. If number gives remainder 17 when divided by 99, that means number can be written like this, isn't it? 99k plus 17. I'm repeating, don't worry. Those who are having any confusion, don't worry, I'm here only. When this number is divided by 99, this gives remainder 17. It means the number is of the form 99k plus 17. Isn't it? Now my question was, when this same number is divided by 11, what will be the remainder? If k is any quotient, I do not know. Rakesh is asking what is k. Pata nahi k kya hai, malum nahi, that's not given. Question mein itna hi given tha. Question mein itna hi given tha. So k can be any natural number, any integer. Why to bother about that? So other than 17, whatever part is there, that is divisible by 19, right? Now question says, what will be the remainder when this same number is divided by 11? See, now this 99k is divisible by 11, isn't it? This is multiple of 11, k kuch bhi ho. It does not depend on the value of k. So how to find remainder? I just need to look for this number 17, which you can easily do. Okay, let's move further. Don't worry, we are going to discuss more concepts also. So I'm just going to recap it fast so that we can start with our today's topic as well. Yes, exactly. बिल्कुल सही बात है. So method which we are using for 99 can be used for finding divisibility with 11 as well. Yes, that was a nice point. That's a very nice point. That's the main point which I was discussing. Now same way for 999, we need to make a group of 3 digits and we have to add them together. Okay, now 999 के factors क्या हैं? What are the factors? So this number is basically 27 into 37. So rule of 27 we get from this 999. Yes, now 1001 is 7 into 11 into 13. So basically these rules are very important for our examination. These rules are very important for examination, although we can go further as well. But generally those questions are not asked, at least in CAT and other exams. For your own numbers exploration, you can go further as well. But at least these rules we must be very clear about. And as I said earlier, the benefit of using these rules is that if the number is not divisible by that particular divisor, we are getting the remainder. Iske alawa, other than this, whatever divisibility rules are there for other prime numbers, as someone was asking for 13 or 19 or 23, there are other rules, but those rules only tells us whether number is divisible or not. They do not tell us about the remainder. That's why they are not very important. Madhavendra is saying video 2x पे play हो रहा है, please slow down. Is anything such? I'm not sure about that. If there is any team member or any of the students, can you confirm? Is there any issue with anything? Okay, let's move further. Okay, so that was yesterday's part. Anything else you discussed yesterday other than this? Anything else other than this which you discussed yesterday? Is there any confusion? You can ask me. I can just spare 5 more minutes for that. Any other thing from yesterday's class which you wish to clarify? Negative remainder, okay, Nandita, point noted. I will soon discuss that. Mode part, okay, don't worry. I'm going to discuss that also. Derivation, किसका derivation चाहिए सौरभ बताइए? Highlight of the day is क्या है? Yes, Aditi, we will solve questions, don't worry. Somebody was asking for derivation. What's derivation? If you can clarify, I will certainly help you. All clear, no doubt. One example of this pratigya for what? Mode part, I have noted down, don't worry. Mode and negative remainder, these two things मैं लिख लेता हूं यहाँ पे. Mode is one thing which you are asking repeatedly, and one is negative remainder. Okay, I have noted down these two terms. Other than this, one who somebody was asking about derivation or something. How to calculate the remainder of big numbers. Remainder आज हम निकालेंगे, so certainly HCF and co-prime. Co-prime also we are going to discuss now. In our last lectures we have not discussed about co-prime. Okay, so no further doubt. Let's proceed then. Somebody was asking for derivation. I'm looking for that comment. Is there anything? I will use questions, Vidushi, don't worry. There are many questions. In today's lecture, there are only 2-3 concepts, and then we are going to solve many questions. Akriti is asking, please explain 101 and 1001. ये लिखा ना बेटा. For 101, what is the rule? Rule is that we need to make group of two digits and we are to make the groups alternate positive, negative, positive, negative. Okay, let me take an example for this. I'm creating some space here. इसको हटा देते हैं. Okay, say if my number is 1, 2, 3, 4, 5, 6. Let's take a small number, not very big number. Terms कैसे लेना है मैं बता रहा हूँ. I'm telling you how to take the terms, how to use these results. Let's take this number and find remainder with all these divisors. Okay. If I want to find the remainder with 9, now finding remainder with 9 means mod 9. Many of you are asking about mode. So mode, as I said earlier also, mode is just a way of representation. That means if I divide this large number with 9, so this number will be now termed as mod 9. So what will be the remainder? So while writing mod 9, basically we are not concerned about the quotient. I'm only asking what is going to be the remainder left. Okay. So now how to find remainder? You all know that we need to make group of single digit and add them all together. So it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. That will give me the remainder. Okay. You can easily add that. So 5 plus 4 is 9. 6 plus 3 is 9. So that leave that. So answer is 3. Right? Wonderful. Okay, now one more important thing which we can learn. 9 के लिए, it is not the only rule कि we need to take single digit because 9 is also a factor of 99. So I can use divisibility of 7. अभी आया हाँ. Okay, I will come that. You are asking about that rule which I have left. हाँ, double the unit digit. I understood. Okay. No need. I will come to that. That's not very helpful result. So I have not discussed that. But anyway, I will tell you why that rule comes. So right now I'm talking about the method to use rule of 9. So 9 के लिए हमने क्या किया? So 9 के लिए I can make group of single digit and add them all together, right? Which we normally do. And after that, from right side, yes, it's better. See, when we are adding the digits, तो चाहे आप left से add कर रहे हो या right से, that does not matter. But actually, we are adding from right. Mohammad Shafuddin Khan, you are asking, explain it deeply. I have explained it very, very deeply in the conceptual videos. Please go through that. It's very easy. It's just place value. Just take an example of two digit number, 56, let's say. Shafuddin, please be careful here. So if 56 is to be divided by 9, so 56 means 5 times 10 plus 6, isn't it? Right? So now 5 times 10. 10 when divided by 9 gives remainder 1. Or basically I can break this number as 5 times 9 plus 1 plus 6, right? So 5 times 9 is divisible. 5 times 1, that is 5 is remaining. So 5 plus 6 will tell me what is the remainder, which we generally call as sum of the digits, right? So don't be confused about that. That is the meaning of sum of digits. Okay, so for 9 I was telling you that adding single digits at a time is not the only result. We can make use of rule of 99 as well or 999 as well. It means that if we are having numbers which are having two digits, that can also be added. For example, let me give you an example. 1, 2, 3, 4, 5, 6. If I include 7, 8, 9, 10, 11, 12, maybe till that point. Now how to find remainder of this number with 9? Can you find the answer fast, please? I'm waiting for your answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is a large number. You have to tell me what will be its remainder when this number is divided by 9. Please find out your answers. Okay, I've got one answer. Shrimi Shankar says 6. Many of you are saying 6. In between I saw some other answer as well, -8 or 3. But most of you are saying the answer 6. Good. Can any of you, 6 is the right answer. By the 6 is the right answer, very much congratulations to all of you. Majority of you are getting the right answer. Very nice. Now, can any of you write how did you get the answer fast? One way is to take a single digits, right? I think यही किया आपने. -3 or 6, that is same thing. Yes, sum of digits. Yes, AP was the important point, right? See, single digits if I add, so 9 तक तो till 9 there are single digit numbers only. After that 1 plus 0, 1 plus 1, 1 plus 2. That's one of the ways, right? अभी छोटा number है इसलिए आप जल्दी कर पाए फिर तो. If I extend this number till let's say कहाँ तक करें? Till 98. अभी बताओ, उसके बाद डिस्कस करते हैं. अरे wait. I'm extending this number till 98. Okay, 10, 11, 12, 13, 14 up to 98. Yes, 98 till 98 I'm extending it. Now how will you do it? Yes, Soham, that's perfectly fine. By using AP, exactly. I'm extending the quotient till 98 now. So all the natural numbers from 1 to 98 are written together to form a large number. Yes, Soham, that's perfectly fine. Sampati, good. See, don't remain stuck to just one rule for divisibility by 9. To calculate the divisibility by 9, we use sum of the digits. That's perfectly fine. But for 9, we can make use of rule of 99 as well, which says make group of 2 and add them together. So that's what we are doing. So basically, when it was till 6 only, we added single digit. But when I'm extending it, so basically 1 plus 2 plus 3 up to 9 to tha hi. After that, we can directly say 10 plus 11 plus 12. Now it is not necessary to make it 1 plus 0, 1 plus 1, 1 plus 2. That can be done, but that will take a long time. So it's better 10 plus 11 plus 12 and so on up to 98. So we just need to find what will be the remainder when this large sum is divided by 9, right? Is it okay? By the way, answer was 6, right? 0 आएगा बाबा, हाँ 0. 0 is the right answer, not 6. This time 0 is the answer. Yes. So the important learning here only is that it is not necessary that always you are adding single digit. Basically make use of the other rules as well. That is the only point. Okay, let me continue. Piyush is asking, sir, लेकिन इस तरीके से single वाला sum and pair वाला sum तो change हो जाएगा. नहीं, that is not required. Single and double together we can club them. There is no issue because we are making use of all these results. So basically, purpose of using these rules is to make the calculations easier, right? Tanmay is asking, why would the first 9 digits be taken as single and not double? No issue. That's what I'm saying. There's no issue. We can do that. And we should use that. Otherwise, if you are going to take single digit, that will take certainly a long time. Okay, तो इसके अलावा आपने divisibility of composite numbers भी किया था. So I'm going to come to that. So it is not important of using AP. Basically, the numbers which I wrote were in AP. They can be in something other way also. But point is that for divisibility by 9, I can make group of 2 digits at a time and then add them. That is the key point. ठीक है ना? We can make group of 2 digits at a time. Suppose I want to find out, let's say 23, 2, 3, 2, 3, and 5, 3. Now this is a 6-digit number. You need to find a remainder with 9. Okay? We need to find the remainder with 9. So we can add single digits. 3 plus 5, 8 plus 3, 11 plus 2, 13 plus 3, 16 plus 2, 18. It is divisible by 9. Right? Or we can make a group of 2 digits at a time also. 53, this is 23 and 23, which makes it 99, which is divisible by 9. So that was the basic point. Okay, let's move further now. So we have discussed all these rules. So basically these rules are valid for all of their factors. So for 9, we have various divisibility rules. We can add single digit together or 2 digits or 3 digits or the combinations as well as I use here. And same way, if you check for 11 also we have various rules. See, 11, we can make a group of single digit, alternate plus minus, or 99 is also having 11 as a factor, right? It is 9 times 11. So for 11, we can also make use of this rule that make group of 2 digits and then add them all. Or 11 is also a factor of 1001. So for 11, I can make use of this rule as well, that is make group of 3 digits and then alternate plus minus. So like that, there are infinitely many rules for 11 as well. Okay? It's not about AP, beta. Many of you are writing AP. It's not AP. It's not AP. AP is just given to make the question easier. It is not necessary to be AP only. It can be anything. So point is that for 9, there are many rules. We have to add the digits. Either I'm taking single digit, or I can make a group of 2 digits or 3 digits and so on. Right? That was the basic point. And same way for 11 also, there are infinitely many rules. So we can make group of 1 digit or 3 digit or 5 digit and so on. So then those groups are to be alternate plus minus. Or if I make group of 2 digit or 4 digit or 8 digit, in that case, the groups are to be added. Okay, let me take one more example for all of this. I'm erasing it and now try to answer this. Let me take a large number and this time I'm removing AP. I'm not using AP. Let me take another number, say 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. Let's stop here. It's a 10-digit number, okay? It's a 10-digit number. Now I want to find what is the remainder when this number is divided by 9. The question is very easy. You have to use the various ways basically. That is the objective. You have to use the various ways. How you can solve it? One obvious way is to add all the digits single. Yes, you can add 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4, right? That is the obvious way. Normally we do by adding some of the digits, which is very easy, not difficult. Now 3 plus 3 plus 3 is 9. This can be discarded. And 4 plus 4 plus 4 plus 4, 16 and 2. 16 along with 2 makes it 18, so that can be discarded. So 1 plus 2, 3 is the remainder, right? That's a very simple thing. So question is not difficult. So my purpose is to understand the various ways to answer this. Okay, now the other way to answer this, as I said, we can make group of 2 digits also. So I can write it as 44 plus this 44 and this maybe 33. Or as I discussed in the beginning, we can make single digit groups as well. So maybe this 1, 3, let it be single digit. Then maybe this 22 and this one single digit. Whatever group is suitable, we can take that. Whatever group is suitable, we can take that. Right? Now let's check that. So what will be the remainder? Now this 44 and 44 makes it 88. Right? 88 and 1 if I club. 88 plus 1 is 89. 89 is 1 short of 90. That gives you remainder minus 1 or it's minus 1. It's 1 short of 90, right? Now 22 plus 3. 22 plus 3 is 25. 25 and 33. Kitna ho gaya? 25 and 33 is 58. So 58 minus 1, that is 57. Now 57 gives you remainder 3. So in this case, it becomes lengthier way, right? So as I said earlier, whatever way is suitable, that we should use. So basically remainder will be 3, whatever method we use. But various methods should be known to us. So we cannot fix down to one single method. कि मैं एक method कर लेता हूँ, मेरे लिए ये काफी है. काफी students ऐसा सोचते हैं. But that may not be a good way always. हाँ, yes, exactly. Some of you have written very nice thing. Yes, good. See, this is 1 times 1, this is 2 times 2, this is 3 times 3, this is 4 times 4. So it's like 1 square, 2 square, 3 square, 4 square, right? I have written the expression that way only. Exactly. Anyway, so that was the way to calculate remainder with 9. So we have to add the digits, whether I'm taking them single or group of 2 or group of 3. Okay, if I need to calculate the remainder with 11. I'm erasing this part now. Now I want to find out the remainder with 11. So how to find remainder with 11? So I'm discussing the various ways. So one way was taking the digits alternate plus minus. So this digit is positive, then next one is negative, then positive, then negative, then positive, then negative, positive, negative, positive, negative, right? So now positive 4, negative 4 cancelled, positive 4, negative 4 cancelled, positive 3, negative 3 cancelled, this is positive 3 and this is negative 2. That makes it positive 1, right? And positive 2 minus 1, that makes it again positive 1. So total it is 1 plus 1, that is 2. That's it. Right? So in this case, remainder comes out to be 2. So that was, we were working with single digit, alternate plus minus. Or we could have made group of 3 digits also. We could have made group of 3 digits. Yes, exactly. We can make group of 3 digits also. So if I'm making group of 3 digits, then 444. This is the first group. See, grouping should be starting from rightmost end. So this group is going to be positive. Then next, it is 334. This is negative. Then 223. This is positive. And this is 1. That becomes negative. Right? Now we can solve it. Now 444 minus 334 is how much? It's 110. Positive, right? 110. This is positive number. Now 223 minus 1. That is 222. Now when we divide this part with 11, we can see this is divisible and 220 is divisible. 2 is the remainder. So this is 2 mod 11. So mod is just a representation, don't worry about that. So 2 is the remainder. So basic point is only that we should understand the various ways to calculate the remainder. In whatever question, whatever way you seem to be more comfortable with and easier, we should go about that. Okay? We can't have single digit, double digit in case of mod 99. No, 99 के लिए तो एक ही rule है Ayush. For 99 there was only single rule. We need to make group of 2 digits. For 9 we have learned that there are various rules. For 11 there are various rules. But for 99 we have understood only one rule so far. Mod representation means only remainder with 11. That's it. This mod 11 means remainder of the given number with 11. That's it. Mod 11 means remainder obtained when the number is divided by 11. That's it. So in place of writing this complete sentence, we just write mod 11. That's it. And in short notation, sometimes people write that way also. When number is divided by 11, what is the remainder? That's it. You know? Absolute difference. How to decide how much? Precisely, we have already discussed that. It's not that we are to decide. That is fixed already, according to the divisibility rules. See, let me repeat the rules. Rules kya tha? 10 power 1 minus 1, 10 power 1 plus 1. So we need to make a group of single digit, right? 10 power 2 minus 1, that is 99, and 10 power 2 plus 1. We need to make a group of 2 digits, right? 10 power 3 minus 1, that is 999, and 10 power 3 plus 1. In that case, 1001, we need to make a group of 3 digits. So group कितने digits का बनाना है, that is already fixed. But there are certain divisors which come into various categories. So for those particular divisors, we are having freedom, and we should make good use of that freedom. That's what we are discussing. Okay. So let me proceed further now. So there may be some bit confusion. So don't worry. While solving questions, they will be clarified. Can we club double digit in case of mod 99 as its factor of 999? Yes, wonderful. That's perfectly Ayush. Kundu, that's correct. Right. So 99 का जो rule है, we have to make group of 2 digits. We can make group of 4 digits as well. That's correct, Ayush. I'm not going to discuss with everyone, but yes, what you have written is fine. That's true. हाँ, yes, ये rule use करके तारुषी जो भी result आता है, that is a remainder. If that remainder is 0, that means number is divisible. Otherwise, you are getting the remainder. हाँ, 27 के लिए भी okay. Let's say यही number है. If I want to find remainder with 27, तो 27 में कौन सा rule काम आएगा? 999. 10 cube minus 1, right? 10 cube minus 1 was 999, which was having factors 27 and 37. So to find remainder with 27, what we need to do? We need to make group of 3 digits and all will be added together. So now this 444 plus 334 plus 223 plus 1. So whatever will be the value, we can find the remainder with 27. We can divide that. Okay. Okay, fine. Let's move further now. Don't worry, we are going to use all these things in the further part also. So don't worry. But practice is the only thing which will make you perfect. Practice is the only thing. Mayank, more than 1.5 hours I am repeating this 11 and 9 only. What's the difficulty in that? Don't worry, there are thousands of your friends here. They are certainly going to help you. Don't worry. Let's move further. You will be clarified. I am moving. Let me erase this. Okay, so now to find remainders. हाँ, divisibility by 7 वाला जो rule था unit digit वाला उसको और देख लेते हैं. You have learned one result basically. ये जैसे मैंने I have already told you this is not very helpful result in our finding questions which involve remainders. We can check whether it is divisible by 7 or not. But otherwise you have learned one rule that, for example, if I am having number maybe say 3, 9, 2, 4, 5, 1, 7, 2, whatever a large number it is. So you want to find whether this number is divisible by 7 or not. So you have learned one method. You take the unit digit, double it, and subtract from the remaining number. Right? You learn this method, and we can continue like this. And in the end, we can check whether number is divisible or not. ठीक है ना? So why does this rule works? So that was the important point here. So let's take the unit digits separately. So make it 10a plus b. Okay, this is the number 10a plus b, where b is the unit digit and remaining number is 10a. This part is multiple of 10. This is a and this is b. ठीक है? So how we are going about this? This is 10a plus b. So if I double it and I'm subtracting it from the remaining number, so basically what I'm doing, I'm saying a minus 2b. The new number formed is nothing but a minus 2b. So let's call it q. So what we are saying if this number is divisible by 7, then this was also divisible by 7, right? That was the only thing. Yes, seed number is the term for that. Riya, that's correct. Kumar, Akash, many of you are saying that. Good. See, so what we need to do here, so to simplify this equation, it would be very easy if I can eliminate this part of b. So for that, I need to multiply this first equation by 2. So let's make it 2p equals to 20a plus 2b. Now just add them. If you add them, what you are going to get? I'm just adding them. So the signs will not change. जो sign है वही रहने वाले हैं. So this is 2p plus q equals to this plus 2b and negative 2b cancel. It comes out to be 21a, which is certainly divisible by 7, irrespective of value of a. ठीक है ना? So whatever number it was, so I have just subtracted the double of this unit digit with the remaining number, that is a minus 2b. So this 2p plus q, that comes out to be 21a, that is multiple of 7. Now think, if this q is multiple of 7, if this multiple of 7, this 21a, this is also multiple of 7, in that case p also has to be multiple of 7. That is a divisibility check. Okay? That is divisibility rule Devanshu, sorry. So if q is divisible by 7, then p also has to be multiple of 7, because their sum is known to us that it is divisible by 7, right? Do you know what is the question, Stuti? Yes, it is divisibility rules. Exactly. If q is divisible by 7, then p also has to be divisible by 7. But if q is not, then p is also not. Why? Because their sum is 21. Okay, now understand one thing. There are two numbers, x and y, whose sum is multiple of 7. Let's say 70 मान लेते हैं. Now all of you answer will come here. We will discuss it later. X plus y is 70. It is multiple of 7. ठीक है? Now tell me, is it possible that both x and y are divisible by 7? Yes or no? Is it possible that both x and y are divisible by 7? Yes or no? Yes, I am discussing the topic only. Don't worry. Is it possible that both x and y are divisible by 7? Why no? Yes, हाँ, क्यों नहीं? Suppose if I take x to be 7 only, in that case y will be 63. Both will be divisible by 7, right? It is possible. Is it possible that none of them is divisible by 7? It's the next question now. Is it possible that none of them is divisible by 7? Yes. If suppose I take x to be 10, in that case y will be 60. Now none of them is divisible by 7. Final thing. Is it possible that one of them is divisible by 7 but other is not? I repeat. Is it possible that one of them is divisible by 7 but other is not? Exactly. Wonderful. So that was the logic used to find out this divisibility rule of 7. And that can be applied for all prime numbers basically. That can be extended for all prime numbers. Okay, so we shall move further now. So we are coming to remainders now. So the numbers, if number is not divisible, in that case, how to find a remainder? With certain numbers, we have found the divisibility rules, we have formed some rules, and we are using that. Priyanshu, I am not sure whether q is divisible by 7 or not. मुझे नहीं पता. अगर q होगा, if q is divisible by 7, that will confirm that p is also divisible by 7. That's it. Don't worry about that. Don't be confused about that. We are just discussing why this method works. Okay. Come back to our divisibility part. You will understand all these things. These are very basic things, easy things. Don't worry. Our purpose is to make the things easier, not confusing. Don't get confused. It's not to confuse. It is to make the things clear. Yes. Don't worry. Euler is also not very important. We have written this term Euler here, but before that we have to understand many more things. Okay, come back here. Now, see, we are going to discuss remainders. We have learned about various types of divisibility rules. Now our major concern is to find the remainder. So whatever we have discussed so far, we have seen divisibility with some particular divisors only, right? With some particular divisors only. But divisors can be many more. You have also learned, I guess, about the divisibility with the composite numbers, right? With composite numbers also, that you have done. But there can be various numbers. There can be very large numbers also. Some of you are asking, what about the large numbers? So if you are having a large number, how to calculate the remainder with a particular divisor? And in CAT, in all other exams also, we get direct questions. Find the remainder. Direct question. Find the remainder of a particular number with a divisor. So how to go about that? Yes, Snehadeep, this method can be, the method which we just discussed, it can be extended for all prime numbers. Anyway, come back here now. Now don't get distracted. So what is the meaning of remainder? All of you know. If I divide any number with any divisor, let me take an example. If I'm dividing 23 with 7, can you tell me what will be the remainder? If I divide 23 with 7, what will be the remainder? हाँ मैं co-prime अभी आएगा, don't worry. 2. Co-prime अभी आएगा इसी में है ना, तो hang on. So 23 को 7 से divide किया, if I divide 23 by 7, remainder is 2, right? See, now I'm using this notation. So don't be bothered by the notation. I could have written like this also. 23 is 2 mod 7. It is one and the same thing. Okay, it is one and the same thing. Vedant, why don't you write on bullet train? Okay, this is one and the same thing. Also, we can write it like this. This 23 is 7k plus 2. Right? That is the equation format. Is it fine? Yes, by default, the remainder is said to be positive remainder. Yes, that's true. That's true, Kanishka. Till this point, is it okay? These are just different notations. So don't get confused by the notations. These are just notations. Fine. Okay. So when we divide 23 by 7, remainder obtained is 2. So when we are writing it like this, so basically a basic point is that we are not bothered about the quotient. What is going to be the quotient? So 23 when divided by 7 leaves remainder 2. It can be written like this: 23 equals to 2 more 7. Or we can write it like this also, that 23 equals 7k plus 2, where k is the quotient, right? So what is the value of k? Maybe parani. It's a small number, you can find out. But if it is a large number, in that case, it may not be easy to find. Fine. Okay. So the number is written as divisor into quotient plus remainder. So while calculating quotients on remainders, this remainder is always going to be less than divisor. What are the conditions going on for this remainder? This remainder is always going to be less than divisor. It can never be more than divisor, right? Divisor se bada hoga to we can again subtract, na? Jay Gupta is asking how 23 is 2 more 7. What is the meaning of this? Yahi to kiya na? 23 when divided by 7 gives remainder 2. That's it. So I could have written more 7 here also. 23 when divided by 7 gives remainder 2. So more 7 is just means that when we are dividing the thing by 7, nothing else. And see one more thing, when I'm saying dividing by 7, so actually what we are doing, dividing by 7 means we are subtracting 7 repeatedly, isn't it? 23 में से हम 7 बार-बार subtract ही तो कर रहे हैं ना. When I'm saying divide 23 by 7, it means make a group of 7 and remove that. Make one more group of 7 and remove that. Make one more group of 7 and remove that. That's what we are doing. ठीक है ना? So whatever is remaining now, that is our remainder. Exactly. So this n is equal to d into q plus r. This d is divisor, q is quotient, r is remainder. In this case, as I have written in this equation format here, this is 23 equals to 7 times 3, that is 21, plus 2. Right? So what I have written here is, this remainder will always be less than divisor. Can it be more than divisor? No. It has to be less than divisor. Because if I calculate it to be more than divisor, we can again make a group of, we can again subtract the divisor from it. Now, also important point is, this remainder is always going to be greater than or equal to 0 also, but only for the answer purpose. So while answering a remainder, this remainder can never be negative, as some of you were writing in the comments. So this remainder is never going to be negative for as answer purpose. But while calculating, we can make the remainder negative as well as more than divisor as well. Okay? So just try to understand what we are discussing here. Now 23 is 7 times 3 plus 2. Is it true? Yes or no? Tell this point. 23 is 7 times 3 plus 2. Fine? Okay, what we have done, we have made a group of 7. How many groups of 7? 3 groups of 7 we have made. That means 23 and 2 is remaining. Now think, if I make one more group of 7, if I take one more group of 7 from here, that means if I make 4 groups of 7, so now what will be remaining? What will be remaining? If I take one more group of 7, that means in a way I'm adding plus 5 and minus 5 here. What I'm doing in a way is I'm adding 5 and subtracting 5, so that I can make one more group of 7. Yes, so it comes out to be minus 5. So when we were saying remainder is 2, I can also say it is minus 5. Why minus 5? Because we have taken one more group of 7, which essentially means I have subtracted 7 from this. And what was 7? 7 is the quotient. 7 was the divisor. So whole point is that, I'm repeating the whole thing, whole point is that whatever remainder we are finding, we can always add or subtract the divisor from it. Jay is asking 23 more 7 is equal to 2 hoga na? Yes, haan, yahi to hai, okay, Jay, that's correct. That's what we have written. 23 more 7 is 2. So more 7 can be put here or here also. Don't be confused in this part. That's the same thing. That is one and same thing. Yes, Nitesh, that is the concept of negative remainders. So how we are making the remainder negative? By subtracting divisor from that. Let's take one more example. Wait. Let me erase this. I'm taking another example now. Let's keep this same number 23 only. Okay, 23 is my number and I want to divide it by, suppose, maybe 9. Now tell me, how many groups of 9 can be formed from here? 2 groups, right? 9 2s are 18. So I can write this 23 as, is 23, 9 2s are 18. So what is remaining is 5. That's it, 5 is the remainder. But for our calculation purpose, see, we are going to do large calculations. So I'm just making the base for that. This is a very simple thing. So this 5, if I need to make it negative, what I need to do? I need to subtract 9 from it. I need to subtract the divisor, 9 from it. So that will make it minus 4. That's true. So this is minus 4. Kyun? Because it becomes 9 into 3 now. This is 27 minus 4. What's the difficulty in that? Right? So because I'm not asking what is the quotient, I'm just looking at the remainder. So this remainder can be plus 5 and it is same as that of minus 4 as well. Now see one more thing. Why minus 4 only? I can subtract 9 again from this, so it can become minus 13 as well. ठीक है, समझ में आ रही है बात ये? So don't get confused. As I said earlier, I'm just making the base. We are going to do large calculations. So this is just base for that. So we can play with the remainder like this. Is it thing clear? Again, mode. Arey Baba, mode is just a representation I have told many times. Don't worry about that. Yes, negative remainders are one and the same. Yes, they are same thing. So 23 when divided by 9, remainder is plus 5 or minus 4 or minus 13 and all that. These are all same thing. These are all same thing. See, right now I have just subtracted the divisor from it. I can add also. If I add 9 to it, what will be the case? If I add 9 to this, it will become 14. Right? So it will become basically 9 times 1 plus 14. That's true. Remainder becomes 14 as well. Yes. So for answer purpose, अगर क्वेश्चन यही पूछ रहा है कि 20 what will be the remainder when 23 is divided by 9, in that case answer is this plus 5 only. But if you are having some large calculations, so during that calculations we can play with the remainder. We can use it as minus 4 or minus 13 or plus 14 and so on. That is only for our calculation purpose, which we are going to do bit amount of time. Till this point, is it okay? Abhishek is asking negative remainder, like how many digit more need to make this divisible? Negative remainder अभी किया ना बेटा, negative बना दिया इसको by taking the one more group. अब purpose क्या है उसका? That depends on the question. Yeah, right now, see, you are not seeing the purpose. ऐसा क्यों कर रहे हैं? That may be the confusion right now. I can understand that. कि ऐसा क्यों कर रहे हैं? Why to do this? So that why will be coming in a while. Right now, just understand कि what we can do. What we can do. Just try to understand that. Right? ये बोया दिवाकर come to today's session. भैया ये परसों का सेशन कर रहे हैं. ये आज ही का है. Understand these things. Is it okay? फिर से यूलर यहाँ पे यूलर गलत लिख दिया हमने. यूलर नहीं लिखना था. Okay, let's move further now. So I hope this part is clear. So what is negative remainder that we have understood, and what are the different representations that we have understood? So don't be confused by that. Let's move further now. Okay, so I'm erasing this. Okay, now tell me what will be the remainder when 2003 is divided by 7. Answer fast. Answer fast. Yes, now we are going to apply all these things. Whatever we have learned, we are going to apply that. कोई rules mix नहीं होंगे. Don't worry. Don't worry. Tell me the remainder. Yes, 1 is the remainder. When 2003 is divided by 7, 1 is the remainder. कैसे किया? कैसे किया? Tell me. Have you just simply divided this number, or have you used any particular method? Yes, 1 is right. Please tell me. Normal division. ठीक है. आशर बोल रहे हैं normal divide किया. हाँ, कनिष्का ने अच्छा चीज लिखी है. 003 minus 2. Wonderful. See, छोटा ही नंबर है, आप सीधा डिवाइड भी कर सकते हैं. Many of you have done that. Abacus सौमित्रा abacus याद कर रहे हैं. Yes, 1001 rule. Yes, perfectly fine. काव्या, Vinny. Yes, that has to be done. So some of you are writing कि सारे rules mix हो गए. नहीं, कोई rule mix नहीं हुआ. We have to use that now. Although this is a small number, we can directly divide it also. But 7, 11, 13 had a rule of 1001. Right? So we could have used that. So what was the rule? You make group of 3 digits at a time, starting from the rightmost end. And then the groups are alternate positive and negative. So 003 is positive and this 2 is negative. So 3 minus 2 gives you 1. Isn't it? That's the remainder. Although this number is small, you could have directly divided also. Many of you have done that. But this is the basic way. Is it fine? हाँ, normal division कर सकते हैं, but it's better to use the rules. Let's move further fast. 2004 divided by 7. Now tell me the remainder. Now tell me the remainder. 2004 divided by 7. What is the remainder? Yes, it's 2. And Mag is writing method also good. 004 minus 2. Sagar Rajput, you have written it perfectly fine. See, this time again we could have made use of the earlier method, that is 004, that is positive number, and this 2 is negative. So by subtracting we'll get 2. But dear students, we should understand one thing here. When we have calculated the remainder of 2003, that it gives remainder 1. So when we are increasing this number by 1, so simply remainder is also going to increase by number 1, isn't it? So there was no need to do this 004 minus 2. This time directly we could have said it increased by 1. Right? Anyway, so this remainder is 2. Now, tell me one thing. If I ask you what will be the remainder when 2003 plus 2004 is divided by 7, please tell the remainder. What will be the remainder when 2003 plus 2004? Doubling the digit वाले से remainder नहीं आता. Some of you are writing that. That's why I said don't go by that method. If you are doubling the last digit and subtracting from the remaining, we do not get the remainder. So don't use that. That does not give the remainder. Don't be confused in this. That's why it's better to use these methods. Okay, what is the remainder here? It's 3. Yes, 1 plus 2. Perfectly fine. See, we could have added the numbers 4007 and then divided by 7. That is one of the ways. But if you see a bit intelligently, this number was giving remainder 1, right? So this number was 7k plus 1. Isn't it? This number can be written as 7k plus 1. And this number is 7k plus 2. Is this point clear? आप इन दोनों को ऐड कर सकते हो, सॉल्व कर सकते हो, इजी पार्ट है, छोटे नंबर्स हैं. बट बेसिकली व्हाट इज हैपनिंग इज दिस नंबर इज 7k plus 1, दिस नंबर इज 7k plus 2. फाइन. नाउ व्हेन आई एम डिवाइडिंग बाय 7, so 7k is divisible by 7 now. Remainder is 1 only. 7k is divisible. Remainder will be obtained by this term only. So basically remainder is going to be this 1 plus 2. When this 1 plus 2 is divided by 7, and now 1 plus 2 gives you remainder 3. Right? So basically what we need to do, we simply need to use the individual remainders. Here remainder was 1, and when this number is divided by 7, remainder was 2. So we need to work with the same operation, 1 plus 2, that gives you 3. It was not necessary to add them first. Fine. Okay, one more thing. Tell me the remainder when 2003 multiplied by 2004 is divided by 7. Tell me what will be the remainder. Tell me fast, what will be the remainder now? Can we still do that 1 into 2, 2? Or we need to multiply? Yes, you are doing that. 1 into 2 is 2. So some of you are doubtful, क्या ऐसा कर सकते हैं क्या? Let's check out. So this number was 7k plus 1. Let me rewrite. This is 7k plus 1. And this is to be multiplied with another number which is 7k plus 2. Right? Now we need to find out when this product is divided by 7, what will be the remainder? Yes, all the other terms are going to be multiple of 7. That's written in the Priyanshu. That's very well put. See, 7k into 7k. This term is divisible by 7, so no need to check. 7k multiplied with 2 is again multiple of 7. No need to check. It is not going to give any remainder. Now this 1 into 7k is also multiple of 7. So only this term, that is 1 into 2, that is going to give us the final remainder. So 1 into 2 when divided by 7 will give remainder 2 only. Right? So as we did in the earlier case, we need to work with the individual remainders while we are adding or while we are multiplying or while we are subtracting as well. Okay? Is that point clear? Sriram is writing ABCD minus 2D rule will not work. Sriram, this will not work for remainders. I have said that. That rule will not work for remainders. That will only tell you whether the number is divisible or not. Okay, till this point is clear? Okay, let's move further. I'm erasing this part. Okay, so, बढ़िया, आगे बढ़ते हैं. So, if I ask you, what will be the remainder when 2003 multiplied with 2003 multiplied with 2003 multiplied with 2003, and let's take total 10 numbers. When this product of 10 numbers is divided by 7, mod 7 I'm writing now. Okay? When this is divided by 7, what will be the remainder? Subhajit is writing 2 power 10, Joy, Gauri, Anisha, many of you writing 1. Shinchan is asking 1 will be the remainder. Socho, aap batao. Yes, it is 1. Why not? See, we had just discussed that product of certain numbers will give same remainder as by the product of their individual remainders, right? And 2003, we just saw that it gives remainder 1 when divided by 7. So 1 into 1 into 1 into 1. It is 10 times. So how does it matter? It is going to remain 1. Perfectly fine. So this answer is 1. You get full points. Let's move further now. No, I'm not ignoring any of the messages. Don't worry. I may not take names of everyone, but I'm not ignoring any messages. I'm seeing them. Okay, let's move further now. Next question. 2004 multiplied with 2004 multiplied with 2004. Let's say take it also 10 times. And same, you need to tell me the remainder when this number is divided by 7. Let's find out first. Arbaz is asking, please elaborate. What do you want me to elaborate, Arbaz? We had just discussed the individual remainder was 1. Let me write it. So this number was giving remainder 1 when divided by 7, again 1, again 1, again 1. And when all these ones are multiplied, that is going to give us 1 only, isn't it? So we need to work on the individual remainders that we just discussed before this, right? Now tell me this answer. Yes, 2 power 10 it is, not 2 into 10. Ria, it's not 20. It's 2 raised to power 10. But 2 raised to power 10 is more than 7 now. We need to simplify it further. Some of you are writing 2, some of you are writing 4. Yes, Kaushik, 1024 divided by 7. That's perfectly fine. So I'm good. 1024 को 7 से divide करेंगे, remainder is 2. Right. बिल्कुल ठीक बात है. Let me write. See, again we need to work with the individual remainders. So 2004 when divided by 7 gives remainder 2. Right. This is 2, again 2, again 2, and so on. Total 10 times we are getting this 2. So 2 multiplied with 2 multiplied with 2, 2, 2, total 10 times. One thing is that this is not 20. Some of you wrote by mistake, I'm sure. This is not 20. It is 2 raised to power 10. This is 2 raised to power 10, which comes out to be 1024. Is it fine? Now we need to find the remainder of this number when divided by 7. Check it now. Now how to do this? You know it very easily. So various ways are there, and we can make use of the same earlier thing, making groups. So this is the positive group, 0 to 4, and this is negative group. So 24 minus 1, 23. 23, it will be same as that of when 23 is divided by 7, and which gives you remainder 2. So 2 is the right answer. Okay? Yes, 2 is the right answer. Good. Okay, before moving further, now important thing here is that this was only 2 power 10, we could have done it very easily. But if it in place of 2 power 10, maybe it is 2 power 100, then it is not easy to find its value. 3 digit के ग्रुप क्यों लिए मैं पूछ रहे हैं भाई, कौन बताएगा इन्हें? Can anyone tell? हमने 3 digits के ग्रुप क्यों लिए हैं? अशर यूलर पे अटके हैं भैया, यूलर आ जाएगा. Yes, 1001 rule. The divisibility rule of 7 is perfectly fine. Good. That's why I'm taking the divisor as 7 only, so that we don't forget the rule. That was rule of 1001. Yeah, rule of 7. Nice. Coming back. Now it is 2 power 100. Now what we can do? Now we do not know the value of 2 power 100. 2 power 10, you knew that it is 1024. So now comes the important point. That it is not necessary to find its value. Actually, we should try to group these powers, these numbers in such a way which gives us remainder 1. I repeat, that's where this Euler comes into the picture. Listen again. We need to break these powers of 2 together. We need to group them together in such a way that we get remainder 1. Yes, man, some of you have written. It's Anil 1. Yes, perfectly fine. 2 power 3. See, if I take 2 multiplied with 2 multiplied with 2, that is 8. And when 8 is divided by 7, remainder is 1. Isn't it? Right? When we make a group of 3 2's together, yes, we can make a pair like this. So group like this, 2 into 2 into 2, that is 8. 8 when divided by 7 gives remainder 1. Or in other words, I can say that 2 cube is 1 mod 7. 2 cube when divided by 7 gives remainder 1. Right? That's simple thing. Now 2 power 3 gives remainder 1. Then 2 power 6 will also give remainder 1. 2 power 9 will also give remainder 1. Basically, 2 raised to power whatever multiple of 3 will always give remainder 1 when divided by 7. Right? So basically, we can break this number as 2 power 99 into 2. Which means this term is going to give us remainder 1. We have just seen that. And into 2 means final remainder 2. So when 2 raised to power 100 is divided by 7, the remainder is 2. Yes, that's what we are doing. We are not learning. We are trying to understand the things. And if you understand the things, then it's not difficult. So try to understand. And in understanding, you need to have patience. Whatever I'm telling you, just try to understand. But whenever you have any doubts, you can certainly clarify. Okay, मैं दोबारा समझा रहा हूँ. Don't worry. This was one example. So अब how to find out कि कितने का group बनाना पड़ेगा? That means what power of a number will give me remainder 1? That is told to us by this Euler's formula or Euler's number. So that's how we come to this topic. Okay, don't worry. I'm coming back to all the things. Yes, that's called Euler's torsion function. Perfectly fine, Aryan. Okay, I think till this point it's okay. Now we are reaching to this point. Here, what is the relationship of this topic with the remainders? I'm erasing this. And now directly jumping to Euler's numbers, we need to understand what it means. Now it is a totally new term. It's a totally new term. Wait, please wait. एक बार पीछे वाली चीज को एक बार यहीं पे छोड़ दो, break it. And now here's another term. This Euler's number. It can also be said to be co-prime numbers. It tells us about the number of co-prime numbers. क्या मतलब है इसका? Yes, co-prime numbers and less than, right? So first we should understand what is the meaning of this co-prime number. So co-prime number means which are correspondingly prime. That means the two numbers which are not having anything in common. I repeat, the two numbers which are not having anything in common, they are called co-prime numbers. There are some different questions going on side by side. Be concerned. Yes, HCF is one, right? We have discussed about this in one of the conceptual videos also. So co-prime numbers means the two numbers when they are not having anything in common or their highest common factor is 1, they are called co-prime numbers. So, for example, 2 and 3. What is their highest common factor? It is 1. So they are co-prime numbers, right? They are co-prime numbers. I repeat, 2 and 19. Yeah, 2 and maybe 15. Let's say 2 and 15. What is their highest common factor? It's again 1, right? So they are also co-prime numbers. So for two numbers to become co-prime to each other, it is not compulsory that numbers has to be prime. Here they are prime numbers, but here 2 is prime, but 15 is not prime. If I write, let's say 15 and maybe 16, what is their highest common factor? Again, it is equal to 1. They are also co-prime numbers, right? So co-prime numbers किसको बोलते हैं? What are co-prime numbers? So those numbers which are not having any common factor other than 1. So they are called co-prime numbers. Understood? So that is the meaning of co-prime numbers. Now this Euler number tells us that number of co-prime numbers less than a particular number n. उसको हम बोलते हैं Euler number, and that is denoted by generally phi n. So phi of n is the number of co-prime numbers less than n. Let me tell you again with an example. So that's the Euler number, and that will help us to find the remainders now. See, as I said earlier, these are new terms. You may not have heard about this earlier. If you're preparing for the first time, those who have prepared earlier or attempted CAT earlier, you may be familiar with this. But otherwise, these are all new terms. So don't worry, have patience. Yes, I'm repeating my end. See, so far what we have discussed, I've just told you what is the meaning of co-prime numbers. So those numbers which are not having any common factor greater than 1 or whose highest common factor is 1, they are called co-prime, right? They are called co-prime numbers. They are co-prime to each other. No single number can be a co-prime number because co-prime means correspondingly prime or relatively prime. That is also a term. Relatively prime. Right? So one number is prime with a particular other number. Okay? That is the definition of prime co-prime numbers. The two numbers which are relatively prime to each other. Like these examples. 2 and 3 are relatively prime. 2 and 15 are relatively prime. 15 and 16 are relatively prime. क्यों relatively prime है? Because their highest common factor is 1. वेरी नाइस, रिपीटर के लिए भी नई टर्म हो सकती है, गुड. So take one more example. Tell me if I take 15 and 18, what is their highest common factor? What is the highest common factor of 15 and 18? I'm coming to your number, Megha. Wait, it's 3. So these numbers are not co-prime, right? So 15 and 18 are not co-prime, but all these are examples of co-prime. They are co-prime to each other. ठीक है ना? So I cannot say that 15 is a co-prime number. No, that does not make any sense. But 15 and 16, they are co-prime to each other, right? I cannot say that's this 15 and 18, they are not co-prime to each other because they are having some common factor. That is 3. ठीक है ना? Their highest common factor is 3. So they are not co-prime to each other. Anyway, so we have understood what is the meaning of co-prime. Now Euler number हमें क्या बता रहा है? It tells us that number of Euler number of n, phi of n. It tells us the number of numbers which are co-prime to n, which are less than n and which are co-prime to n. For example, if I talk about let's say phi of 100. तो now ये हमें क्या बताएगा कि how many numbers less than 100 are there which are not having any common factor with 100. I repeat. So phi of 100, but generally it is written E also. Some people write like this, E n Euler of n, Euler number of 100. So whatever notation we may use, that's okay, no issue. So what does it tell us? It will tell us that how many numbers are there which are less than 100, and which are not having any common factor with 100. Okay, now think, if I'm writing those numbers which are not having any common factor with 100, so what all numbers will come in this category? Smallest number क्या होगा? What will be smallest number? Of course, 1 should be there. Right, 1 should be there. After 1, 3, yes. 1 will be the smallest one. 3 will be there. 2 will not be there, na? Because 2 and 100 are not co-prime. They are having 2 as a common factor. So 3 will be there. 4 होगा क्या? 4 will not be there, right? 5 नहीं होगा? अरे, you are skipping 5? Yes, 5 will not be there. Why? Because 5 divides 100. 5 and 100 is a common factor. So 5 will not be there. 6 will not be there. 7 will be there, right? So Joy, 5 will not be there, na? Because 5 divides 100. Right? So 7 will be there, 8 will not be there, 9 will be there, 10 will not be there, 11 will be there, है ना? Then 12 will not be there, 13, 14 नहीं होगा, 15, 16, then 17, 18 नहीं होगा, then 19, then 20 will not be there, but 21 will be there, 22 will not be there, but 23 will be there, and so on. There will be many numbers, right? Can you observe one thing? Deepak is asking why 1? What is the highest common factor of 1 and 100? It's 1 only, isn't it? So 1 is co-prime to everyone, so 1 will always be considered. ठीक है? Ishika is also asking that. So 1 is co-prime to everyone because 1 and 100 they have a highest common factor 1. With any natural number, highest common factor of 1 is going to be 1 only. So 1 will always be included in all the list of co-prime numbers. So we are just writing. Why not 8? Deepak is saying. भैया दीपक आप बताएं 8 और 100 का highest common factor 1 है क्या? It's not. Right? So we are writing the co-prime numbers of 100, which numbers are co-prime to 100 and less than 100. ठीक है ना? Yes, Tayalchi, I have written both the symbols. You may use any, whatever, no issues. The notation is not very important. What does it mean? That is important. So we are writing some of the numbers, and there are certainly going to be many more numbers. But it will be difficult if I write all the numbers. Now, can you observe one thing here? That while calculating total number of such numbers which are co-prime to 100, which numbers I am removing? I am removing multiples of 2, right? I am removing multiples of 2. Multiples of 2 cannot be considered. Why? Because 100 is itself multiple of 2. Yes, Joy, that's correct. So also we are removing multiples of 5. The same reason, because 100 itself is multiple of 5. Exactly. So we just need to remove the multiples of 2 and 5. Why? Because 100, if I do its prime factorization, it contains 2 and 5 only, right? Is it not? Right. Now comes the important part. See, 100's prime factorization was 2 square, 5 square. So from here only we could see this, that 100 contains prime number 2 and 5. So we are removing all multiples of 2 as well as all multiples of 5. So how many number remains now? That is the important part. So that is given by directly this result. I'm writing that here. So it says this 100 into, the prime numbers are 2 and 5. So I need to write it like this: 1 minus 1 by 2 and 1 minus 1 by 5. 2 was the prime number here and 5 was the prime number. Their powers are not important. Which prime numbers, multiples of which prime numbers we are to leave, we have to just write that. So this is 100 times 1 minus 1 by 2, 1 minus 1 by 5. That will give us the total number of numbers less than 100, less than n, and which are co-prime to 100. So if I simplify this, it is 100 into 1 by 2 into 4 by 5. You can very easily simplify. It comes out to be 40. I will tell you how did I get this. I will tell you, wait. But find out the answer first. Is it fine? Dija, I have just written the expression, how to calculate Euler number or Euler value of 100. So this is this depends on the prime factorization or the prime numbers contained in this number that we can see easily from its prime factorization. This is only having 2 and 5 as the prime numbers. So their powers are not important. I just need to see which prime numbers are there, right? So how I'm writing the expression? It is 100 times 1 minus 1 by 2 into 1 minus 1 by 5, which upon simplification gives me the value of Euler number. So we have to just consider the prime numbers. We are not bothered by the powers. So if I'm leaving out all multiples of 2, क्या multiples of 4 अपने आप से नहीं हट जाएंगे? Yes, all multiples of 4 are also left out. Similarly, when I'm removing all multiples of 5, of course, multiples of 25 are also removed. Okay? So in general, for a general number, how we can write it? Let me erase this part. Okay, so in general, if you are having any number n whose prime factorization goes like this, that p1 raised to power a, p2 raised to power p, b, p3 raised to power c, and so on. This is just a prime factorization as we written earlier also. So p1, p2, p3 are different prime numbers with their respective powers. So now this phi of n or Euler number of n, it is given by this expression similar to this one. It is n into 1 minus 1 upon p1 into 1 minus 1 upon p2, 1 minus 1 upon p3, and so on. Now, in the questions of remainders, when we are going to discuss remainder theorems, we are going to make use of this value of phi n basically. So we need to understand how to calculate this phi. हाँ 40 कैसे आया वापस समझा दीजिए. 40 हमने यही किया. We were calculating phi of 100. So 100 का prime factorization, that was 2 square 5 square. It was only having two prime numbers 2 and 5. So we just plugged in the values. So it is 1 minus 1 by 2, 1 minus 1 by 5. That is 1 by 2, and that is 4 by 5. So 100 times 1 by 2 into 4 by 5 gives you 40. That's the basic way. Many of these questions have appeared. Don't worry about the syllabus. क्या आता है क्या नहीं आता क्या आएगा. Don't worry. This is very basic thing. अभी तो काफी easy हो चुका है CAT. Present level of CAT is quite very easy. If you see the questions of some 15-20 years ago, then you will see what was the height of questions. This is a very basic thing. Anyway, so right now we have understood this part. So what is Euler number or Euler's value? So for any number we can calculate it like this. ठीक है ना? Okay. Before I move further, ऐसा क्यों करते हैं वो बात अभी बाकी है. I told you this will be used in calculating remainders. वो भी हम अभी आपको करके बताएंगे. We will discuss that. But first understand कि ये क्या करना है हमें. Okay. Before I move further, tell me the value of phi 120. Calculate the Euler's value for 120. Please calculate fast. Okay, many of you are getting the right answer. Yes, that's correct, 32. So first step is we need to find its prime factorization. So this 120 is basically 2 cube into 3 into 5, right? This is 15, 8 is 120. So basically 2, 3, 5, these are the three prime numbers. So we have to consider. So the value comes out to be 120 into 1 minus 1 by 2, that is 1 by 2, into 1 minus 1 by 3, which is 2 by 3, and finally 1 minus 1 upon 5, which is 4 by 5. Right? This you can very easily find out. 5 is 15 into 30, 30 makes and 4, 4 4s are 16 and 2, 32. So 32 is the value here. Right? Yes. So basically you understood the process how we have to calculate this value of phi. Okay, do one more. What will be phi of say 17? Now 17 itself a prime number, right? Phi of 17. Sunil, please recheck how you are getting 2. Yes, it is 16. Right. There is only one prime number, 17 itself. So it is 17 times 1 minus 1 upon 17, that is 16 by 17, or effectively 16. So that is an important learning from here. For every prime number you will find this value of phi comes out to be that prime number minus 1 only. For every prime number it is going to be the case. Yes, exactly, Hetvi, perfect. Euler number for n will be n minus 1 for all prime numbers. Yes, perfectly fine. Okay, so far we have understood what is the meaning of Euler's number, what is the meaning of coprime number, how to calculate Euler number for any number now. So we have taken the example of 100, 120 and now 17. अंकित कुमार अभी भी पूछ रहे हैं कैसे. Okay, स्तुति काहे रो रही हो? Okay, take one more example then. One more? Okay, one more, 16. Okay, 16. What is phi of 16? Please calculate everyone fast. Method you have already done. This is the method in the box. Do the prime factorization of the number, find out the prime numbers, and then apply this expression, apply this result. Yes, just use this formula. Phi of 16 you have to calculate now. Okay, many of you studying. Karthik, गलती कर दी ना, 15 कैसे आया? It's not 15. Please recheck. Yes, 8 is correct. हाँ, शिवांगी, good question. What does it actually mean? ये meaning हम बताए थे यहाँ पर. What is the meaning of this E or Y, whatever you are writing? What is the meaning of this? It tells us that how many numbers are less than that particular number and are co-prime to it. That is the practically meaning of this. But abhi just within 1 minute we are going to use it to find remainders. Pranjal Gupta, it's not Wilson theorem. ये Euler के नाम पे इसको Euler theorem ही बोलते हैं. But anyway, that name is not very important. Yes, fine. So this is 5 of 16. Here 2 is the only prime number, so its value comes out to be 16 into 1 minus 1 by 2. I'm using the same expression. So 1 minus 1 by 2 is simply 1 by 2, and 16 times 1 by 2 is 8. As many of you have got it correctly. Fine. Okay, let's move further. I'm erasing all this part now. So let's move further. So now use of this Euler number in divisibility. How to use it? How to use it? So basically, this is the remainder theorem which we are going to discuss now. If you are having a large number, by large number I means something raised to power something. For example, I want to find a remainder of a number maybe 37 raised to power maybe wait. 37 raised to power 41. We have to find its remainder with, let's say, 100, more 100. ये हमें निकालना है. ठीक है? What will be the remainder when 37 power 41 is divided by 100? That's the question we want to find out. So it's difficult to calculate the remainder. 37 is a prime number, 41 also is a prime number. उनको multiply करते रहेंगे तो 100 से multiply करते करते बूढ़े हो जाएंगे. And it will be difficult. So now this remainder theorem or Euler's remainder theorem that comes to rescue. So what does it tell? Now try to understand this. This remainder theorem, we are just going to understand this theorem today. That's our only topic. So this Euler theorem tells us that if I want to divide any number of this form, m raised to power something. So as we were discussing earlier, we need to make a group which gives remainder 1. We need to make a group of certain number of m's which give remainder 1 with the divisor. So it tells us that what power of m will give remainder 1 when divided by any divisor. So it says that m raised to power 5 of n will give remainder 1 when divided by the divisor n. I repeat, that's our remainder theorem here. What does it tell us? Don't jump to the answers finally. See here. Okay, see here. So m raised to power 5n, खाना साथ में खा लो कुसुम. No problem. So m raised to power 5n gives remainder 1 when divided by the divisor n. See, as in, remember I was asking you in the just a few minutes ago that what will be the remainder when 2 power 100 is divided by 7, right? So it was difficult to calculate the value of 2 power 100. At that time we figured out that 2 power 3 gives remainder 1, right? At that time we saw that 2 power 3 when divided by 7 gives remainder 1. So we made group of 2 power 3. How many groups? 33 groups. That makes it total 2 power 99, and 1 2 was remaining. That's how I did it. That each of this group was giving remainder 1. So 1 1 1 1 into 2 was giving final remainder is 2. So at that time we bothered about this, that how to figure out कि कितनी power पे remainder 1 मिलेगा. So that is going to be found by using this remainder theorem here, Euler's theorem. It tells us that m raised to power 5 of n will give remainder 1 with the divisor n. तो जब भी n से divide करना है, n कोई भी divisor है, तो find out the 5 of n, and that power will certainly give remainder 1. But here is one small condition, and what is the condition? That is m and n, they should be co-prime. That means their highest common factor should be equal to 1. So that is the important theorem which we are to understand, remember, and use now. मैं फिर से बोल रहा हूँ. हाँ. Yes, there are many new things to learn. I'm repeating, don't worry. So my purpose is to find out that what power of a particular number will give remainder 1 when divided by a certain divisor. ठीक है, किसी डिवाइजर से डिवाइड करने पे कौन सी पावर पे जाके रिमाइंडर 1 मिलेगा. जैसे कि अगर यहीं पे बात करूं तो आई वांट टू फाइंड आउट कि 37 की कौन सी पावर को 100 से डिवाइड करने पे रिमाइंडर 1 मिलेगा, राइट? व्हाट पावर ऑफ 37 विल गिव रिमाइंडर 1 व्हेन डिवाइडेड बाय 100? आई डू नॉट नो द टेबल ऑफ 37. आई डू नॉट नो द वैल्यूज ऑफ 37 स्क्वायर, 37 क्यूब, राइट? दैट्स डिफिकल्ट पार्ट. सो नाउ वी आर गोइंग टू मेक यूज ऑफ दिस थ्योरम. इट टेल्स अस दैट व्हाटएवर इज योर डिवाइजर, एज इन दिस केस इट इज 100, सो 5 of n, that power of that particular number will give remainder 1. But the condition was that this number m and this divisor n, they must be co-prime. Their highest common factor should be 1. Okay, let's come back here. See, just relate it with this one. It will be very easy for you. Now see, this is our m here, 37, isn't it? And 100 is my n. Can we apply this theorem in this particular question? First tell me yes or no. Can I apply this same theorem in this question to find this remainder? What do we need to check? Whether we can use it or not. How do I get to know? I need to see this condition that HCF of m and n should be 1, right? And here this 37 and 100, they are co-prime. They are not having any common factor, right? So we can use it. Wonderful. Yes, they should be co-prime. Excellent. So that is the first thing we should check. Don't apply it directly blindly. If you apply it blindly, तो ये numbers हैं, ये कुछ नहीं बोलेंगे, कुछ ना कुछ बन के आ जाएंगे, but that will be wrong. So that is the first thing we should clarify, that this number and the divisor must be co-prime, which is here, which is there in this case, right? Next step, I need to find जो भी divisor है, what is the value of its phi. That means in this case I need to find the value of phi. So first step was that HCF of 37 and 100 is equal to 1, right? So we can apply the Euler's theorem. Next step, I need to calculate the phi of the divisor, phi of 100. We have just calculated it, right? How much it was, remember? What is phi of 100? What was phi of 100? Please tell me. Yes, it was 40. Right? We had just did this. We just did this earlier. Now, this theorem tells me that this number, that is 37, raised to power this phi and 40, will give us remainder 1 when divided by this divisor 100. Is it fine now? That is a result of this theorem. Now, applying this result here, I can break my number 37 power 41 as 37 power 40 into 37 power 1. Isn't it? Now, this term is giving us remainder 1. So, 1 into 37. So, final remainder is simply 1 into 37 or 37. Is it understood? Yes, remainder is 37. Priyanshu, add थोड़ी ना करना है. They are multiplied ना? Right? It is 1 into 37. Yes, don't worry, we are taking more examples. See, understand the steps. First, we need to remember this theorem. So, this theorem is Euler's remainder theorem, or just remainder theorem we can say. So, condition is the number and divisor should be co-prime. That HCF of Mn is 1. That's first thing. Then, we calculate the phi of this divisor. It is phi n. Now, this remainder theorem tells us that m raised to power phi of n will give remainder 1 with this particular divisor. Okay? So that's what we applied in this case. So 37 पर 41 का remainder हमें निकालना था 100 से. First I saw that this 37 and 100 they are co-prime because their HCF is 1, right? So I can apply this theorem. Now second step, I need to calculate the value of phi for this divisor 100. So phi of 100 is 40. We had already done this. Second step, final step, that according to this theorem, this number 37 raised to power 40 will give me remainder 1. So that was basically my objective. That at what power of this number I am going to get remainder 1, so that I can reduce the question. I can make it easier. So 37 power 40 will give me remainder 1. So I can easily break this power in the terms of 37 power 40 now. So this is 37 power 40 into 37 power 1. So this term gives remainder 1. So 1 into 37, finally my remainder is 37. Okay, let's solve one more question now. Now this concept will be very clear to you. Please answer this fast. Find the remainder when 37 power 49 is divided by 40. Please solve it fast, everyone. Rakesh is asking if the n would be not 37, still it would be 40. I just need to see whether my number and divisor are co-prime or not. If they're co-prime, then I can apply. And that phi depends on divisor only, not number. Okay, Harsh is saying 2 per 100 more 7 crore. Bilkul karte hain, don't worry. I'll return it here. I will do this after this one. Okay? Challenge accepted. Okay. Many of you are getting the answers. 37, 37, 37. Nakshatra, I told you, while writing the answers, answer will always be a non-negative number. In calculation, we may use negative remainder, but not as the answer. Okay, many of you are getting it. Let's check. So, can we apply the theorem here? Yes, because our first check was that this number and the divisor, they must be co-prime. So 37 and 40, their highest common factor is 1. So we can apply the theorem, right? Now, next step was to find out what power of 37 will give remainder 1. For that, I need to find the phi, Euler's value, Euler's number for 40, right? So 40 ka prime factorization contains only 2 and 5. So it is 40 times 1 minus 1 by 2, that is 1 by 2, into 1 minus 1 by 5, which is 4 by 5. That upon simplification gives you 10 4s are 40, 4 4 16. Right? So as per the theorem, we get that 37 raised to power 16 will give you remainder 1 when divided by 40. Isn't it? That is the result of our remainder theorem. Now this power 37 power 49, it can be broken as 16, 16, 16 and 1. Right? So 37 power 16 wale there are 3 groups and there is 1 37. So 37. So we need to calculate the remainder for this part. This is 1 into 1 into 1, that is 1 cube, 1 only. So again 1 into 37. Again remainder is 37. Sumit is asking, sir, we can also do 37 power x mod 40 where x is 49. X is 49 more. Euler of 40. Euler of 40 we have calculated now. Euler of 40 is 16. Euler value for 40 is 16, not 49. Okay, अब समझ में आ गया तो मजा आया. Okay, nice. Okay, those who are having any doubt, let's solve another question. Ria is asking 999 power 41 mod 100. Excellent, Ria, wonderful. Yes, correct. Ria has written 999 raised to power 41 का remainder with किससे पूछा था? कहाँ गया? अरे नहीं हो गया. I think 100 था. इसका remainder 100 से कितना आएगा? Yes, please, everyone in the chat box, please write the answer. 999 power 41 का 100 से remainder. हाँ, there is a question in comments. If then they are not co-prime, then what will happen? That we'll discuss later. होल्ड ऑन फॉर दैट थिंग. अगर वो कोप्राइम ना हो तो क्या होगा? विल डिस्कस अबाउट दैट. वेट. Here, what will be the remainder? 999 power 41 divided by 100. See, they are co-prime. Yes, so we can apply the theorem. 5 of 100, same 40. So remainder is going to be 999, right? So whatever 999 will give us with the remainder with 100, that's the answer. And 999 को 100 से divide करेंगे तो remainder is 99. Yes, that is perfectly fine. Good. Excellent. Coming back to this question, somebody asked this question. 2 power 100 का 7 से remainder निकालना है. Can we apply this theorem? Can we use this theorem? Yes, we can use this theorem because 2 and 7 are co-prime, right? Applying this theorem. What is 5 of 7? Please tell me. What will be phi value of 7? What will be Euler number for 7? Now 7 is a prime number. Somebody is asking, explain the last step. Okay, Rudra, see here now. Yes, 7 is a prime number, the Euler number here is 6, right? So Euler theorem tells me that 2 power 6 will give me remainder 1 when divided by 7, isn't it? So according to Euler theorem, 2 power 6 will give remainder 1. Fine, let's use that. So 2 power 6 will give remainder 1, 2 power 6 will give remainder 1. So 6, what is the nearest multiple of 6 till 100? It's 96, right? So I can write this part as 2 power 96 multiplied with 2 power 4. So now 2 power 96 is going to give me remainder 1. So my final remainder will be through 2 power 4 only. Now that you can do easily, 2 power 4 is 16, which upon division by 7 will give you remainder 2. So that is your final answer. So that is the final answer, final step. So somebody, those who were confused about the final step, we are just going like this. So I don't need to write mode 7 repeatedly or whatever way. That was just representation. I hope now your fear of mode function or mode operation is clear. This is not to make you fearful. It is to ease the things. थोड़ा कॉम्प्लिकेटेड हो गया. क्या कॉम्प्लिकेट हो गया प्रथम? तुषार, अरे बाबा 2 power 100 का 7 से रिमाइंडर निकालना था, राइट? 2 and 7 are co-prime, so I can apply the theorem. Theorem tells me that 5 of 7 is 6, which means 2 power 6 will give me remainder 1. ठीक है ना? So now I am making groups of 2 power 6. Because 2 power 6 or any multiple of 6, that will give me remainder 1. So among 2 power 100, 2 power 96, this 96 is multiple of 6 wala power, right? So 2 power 96 will give remainder 1, isko jaane do. So 2 power 4 say I need to calculate the remainder now. Now 2 power 4 means 16, 16 gives remainder 2 when divided by 7. That's it. If go by Euler's method, then how will calculate 2 power 4 by 7? आरती उसमें Euler का क्या यूज करना है? Euler का हम यूज करते हैं when we are having a large power. If my question is that only कि 2 power 4 का 7 से रिमाइंडर निकालना है, why we are going to make use of Euler here, right? 2 power 4 is 16, directly we can do it. Because Euler is telling you that 2 power 6 will give you remainder 1. तो अगर power 6 से कम ही है जैसा कि यहाँ पे आप बोल रहे हो, तो we can directly solve it. We will have to directly solve it. ठीक है ना? In that case, Euler is not going to be very helpful. Euler will be helpful only when the power is a large number, at least more than this Euler number value. ठीक है? Okay, let's move further now. So this question we have covered and the doubts also we have discussed. Let's move further. Here's one more question. Please solve it fast. Ritika, how did we get 2 power 96? Because 96 is multiple of 6. So 2 power 6 वाले 16 ग्रुप मैंने बनाए थे. Please answer this question now. One 47. Please check your answer. There should not be any mistake. अरे जीरो कहां से आ गया आदित्य? 72 is an even number. ये तो odd number है. जीरो तो आ ही नहीं सकता. First step, tell me, can we apply Euler's theorem here? That means 47 and 72, are they co-prime? Yes. HCF of 47 and 72 equals 1, right? So we can apply the theorem. Next step, I need to calculate the Euler number for this 72, the divisor. कितना आ रहा है, please tell me? What is the value for phi or Euler number here? It's 24. The prime factorization contains this is 8 into 9, that is 2 and 3 only. This is 72 into 1 minus 1 by 2, 1 minus 1 by 3. कैसे पता लगा? Because 72 is 2 cube into 3 square. So I just need to make use of this 2 and 3. So 1 minus 1 by 2, 1 minus 1 by 3, which is 72 into 1 by 2 into 2 by 3. That gives you 24, right? So phi of 72 comes out to be 24. Next step, which tells me from this theorem, I got to know that 47 raised to power that 24 is going to give us remainder 1 when divided by the divisor 72, right? Here power is 48. It's okay. If there is one more 47 power 24, that will also give remainder 1. So basically 47 power 48 gives remainder 1. That's the answer, right? So remainder is 1. Yes, एक remainder आएगा. Most of you got it right. हाँ, 0 नहीं है. Don't do this mistake. ये आसान सवाल है. ये आसान क्वेश्चन दिए जानबूझ के यहाँ पे ताकि आपको थोड़ा सा कॉन्फिडेंस आ जाए. Actually पेपर आप देखोगे तो देयर विल बी मेनी tedious questions also. But basically our purpose right now is to for you to have some confidence कि हाँ मुझे समझ में आ गया how to apply the method, what is the method and how to apply it. Okay, let's move further now. Okay, let's move further. Next step is now कहाँ गया? हाँ ये रहा. There's one more question. That's a very easy question. Do it fast. Diksha, 5-10 more minutes please. I will just take 5-10 more minutes. Don't worry. Harsh, I remember your question. If they are not co-prime, I don't think we will discuss it today. So leave it for now. We'll discuss it later. But keep this question in your mind. We'll discuss it later. If numbers are not co-prime, then how we can solve it. Right now, try to answer this. See, check it. This is an example. They are not co-prime now. They are not co-prime. So how to do? This is 27. Can you find out their HCF? कितना common factor आ रहा है? These are not co-prime. What common factor are you able to see? कैसे पता है common co-prime नहीं है? What is their common factor? What is their highest common factor that you can see? 3. Okay. Is this number divisible by 3? Let's check. This 9 is divisible by 3. 5 plus 4 is divisible by 3. And 3 itself is divisible by 3. And 8 plus 7 is also divisible by 3. That's you are all right. Perfectly fine. 3 is the common factor. And some of you are saying 9 is the highest common factor. Okay. No problem. But basically they are not co-prime. They are not co-prime. If I take 3 only, आपको अगर 3 ही दिखाई दिया मान लेते हैं तो 3 लेते हैं एक बार के लिए. So if 3, this number is multiple of 3, right? This is 3k raised to power something. 7, 7, 7, 7. Right? This number is at least multiple of 3. ठीक है, 9 का भी multiple होगा, it's okay. But 3 का आपको इसीलिए दिखाई दिया. So if this is 3k raised to power 7, 7, 7, 7. I want to divide it by 27. Can you think one thing? क्या ये number, ये पूरा number 27 से divisible होगा कि नहीं? Is this number divisible by 27 or not? Yes, Sagar is saying 0. Okay, Riya को doubtful लग रहा है, Riya already know. Sagar बोल रहे हैं yes. आरती कह रही है yes, divisible होगा. Yes, it is divisible. See one thing. 3 power 4. Let's take for this number. 3 power 4. Is this number divisible by 27? Anirban बोल रहे हैं नहीं पता. Let's check. Let's check. 3 power 4. Is this number divisible by 27? Remember that 27 is 3 power 3. है ना? 3 power 4. Is it divisible by 3 power 3? Yes. If I make it 3 power 41, now is it divisible by 3 power 3? Yes. So basically the moment I am having 3 power more than 3, जैसे ही ये power 3 से ज्यादा हो जाएगी, this number is certainly divisible by 3 power 3. So in this case also, if you are unable to figure out whether this number is multiple of 9 or multiple of 3, 3 भी काफी है. Now power is 7777, right? This number is certainly divisible by 3 power 3. क्या ये 3 की power 3 से divide नहीं होएगा? It will be, right? Because this number multiple of 3, 3k, again 3k, again 3k, again 3k. How many times? 7777 times. तो क्या ये नंबर 3 power 3 से divisible है कि नहीं है? Yes, it is divisible, right? So basically this number was multiple of 3 and we are having a product of 7777 such numbers. So this product is certainly going to be divisible by 3 into 3 into 3. What's the harm in that? That means remainder is how much? What will be the remainder? Yes, remainder is 0. Or 3 से divisible कैसे check किया? I think if somebody is asking, yes, we use the divisibility rule of 3. Sum of digits, yes. So here answer is 0. That's why I said this question is very easy. Okay, you want to finish now? Let me see what is left now. There's one more question. You can do very easily. The negative remainders, we have already done that. There are some questions. Let's finish with this question. Let's finish with this question. Yes, let's finish with this question. Please answer this question and then we shall finish. नहीं भाड़ में नहीं भेजेंगे, don't worry. 61 power 217 divided by 9. Yes, wonderful, Pradyumna. But we need to find remainder with 9. So remainder cannot be more than 9. Yes, mine, same thing. Remainder cannot be more than 9. Yes, Kaushik Chaudhary, that's perfect. Anjali, Sarvesh, yes, 7 is the right answer. Good. 7 is the right answer. 61, those who are having any doubt, just clear now. 61 and 9 are co-prime. HCF of 61 and 9 is 1. So I can apply the theorem, which asks me to find the Euler value for 9. It comes out to be 9 into 1 minus 1 by 3, that is 6, right? And now 61 raised to power 216, which is multiple of 6, will give me remainder 1. So remaining term is 61 only. So I just need to find the remainder of 1 into 61, that is 61 with 9. And if I divide the 61 with 9, my remainder comes out to be 7. So that's the right answer. So we shall stop here. Okay. So thanks a lot. I hope you have understood. And I know आज मैंने आपको बहुत ज़्यादा दिमाग लगवा दिया है, but that's going to be really very very fruitful. So please practice. Yes, practice more questions. And जितना ज़्यादा practice करेंगे उतना ज़्यादा आप अच्छे से समझ पाएंगे. Add का what you want to me explain again. We have done the same thing, same steps. We see all the things, and whatever steps you are facing any difficulty, you can ask me. Thank you everyone. Good night. Thank you very much. Thanks Aditya. I'm still here. If anyone is having any doubt, you can shoot it. Thank you Riya. Thank you Karthik, Prerna. सत श्री अकाल सिंचन. प्रथम is asking एक बार लास्ट पार्ट बता दो. ओके, लास्ट पार्ट. नक्षत्र is asking 27 का डिविजिबिलिटी टेस्ट इन प्रीवियस क्वेश्चन. 27 का डिविजिबिलिटी टेस्ट हमने यूज ही नहीं किया था वहां पे. वी डिडंट यूज दैट. वी जस्ट फाउंड दैट नंबर इज डिविजिबल बाय 3. और मैंने आपको यह बताया था कि 3 की पावर जब 7777 हो गई तो इट इज डिविजिबल बाय 3 पावर 3. दैट्स इट. सो वी डिडंट यूज द डिविजिबिलिटी रूल ऑफ 27 देयर. हाँ, see last step. Tanishk is again asking the last step. So this was the thing here. So 61, 9, HCF 1, 5 is 6. So 61 power 6 will give remainder 1. So what I'm doing is I'm just breaking this whole number in the groups of 61 power 6. See, according to the theorem, 61 power 6 will give me remainder 1 when divided by the divisor 9, right? तो 6 का कुछ भी मल्टीपल हो, 61 पावर 6 कितनी बार भी आएगा, रिमाइंडर 1 ही देने वाला है ना. So that's what we are doing here. That 61 power 6 उसके 36 ग्रुप बन जाएंगे पूरे. That makes it 216, and now I'm left with 61 power 1. That was the last step. So this part is giving remainder 1. 1 power 36 is 1 only, and final remainder from 61, which is 7. When the numbers are not co-prime, we have seen one example, and there will be many more examples to solve questions. There is nothing new I need to tell. You just need to apply it cleverly. Give example when the numbers are not co-prime. Yes, I have just told that. Non co-prime वाला explain कर दो. Non co-prime क्या होता है? अच्छा, when their numbers not co-prime, we took the example ना. How did we get 7? अरे 61 को 9 से divide तो कर सकते हो भाई. You can divide it or just use the sum of the digits. 6 plus 1, that is 7. है ना. 61 को आप डिवाइड करोगे 9 से तो क्या रिमाइंडर बचेगा. यू कैन डिवाइड इट एट हाउ मच 9 5 45, 9 6 54. 54 के बाद 7 बचा. दैट इज वन ऑफ द वेज. और डायरेक्टली यू कैन ऐड दैट डिजिट 6 plus 1 7. दैट इज द वे टू कैलकुलेट रिमाइंडर विद 7. बड़े नंबर्स का HCF कैसे पता करें, तो उसके लिए गो एंड चेक ओवर द वीडियो ऑफ हाउ टू कैलकुलेट HCF एंड LCM. वी हैव डिस्कस दैट इन डिटेल. यस निर्णय, दैट्स थैंक यू. उसमें HCF LCM निकालने की काफी सारे मेथड मैंने एक्सप्लेन किए हैं. CAT 23 quant was tough. There may be some questions which are tough, and generally it is pretended. It's not. I'm telling you in comparison with all other years, previous years. अभी currently कुछ सालों में difficulty और gradually increase हुआ है. So maybe CAT 23 was tougher in comparison to 22, 21. But if you compare it with the actual level of CAT, at least in the paper-based test, so it's quite low, very very low actually. Okay, 2024 will be tougher. Who knows? पोर्टल पे CAT 24 वाली वीडियो देखनी है या कौन से वाली? HCF LCM जहां पे मिलेगा, you check it out. I have not seen the dashboard, so I'm not very sure about it. CAT 23 arithmetic, geometry and number were easy. No, easy and difficult are relative. Leave that. Practice right now. Practice. Quant section has some syllabus to practice, so that it's why it is getting tougher. There are various topics from which we get questions, so it is not tougher. At least we are fixed thinking what we are going to learn. In LRDI or in verbal, there is no fixed syllabus, so there can be anything. What is paper-based test? Paper-based test means when CAT used to give a printed question paper, and you need to answer that. That was a paper-based test. Nowadays it is computer-based test. Number topic 9 HCF LCM. Thanks, Akarshita. पुराना वाला भूल गया number factors. Don't worry, Ashish. Resolve questions. Practice makes the man perfect, and women also, of course. Nandita, please explain previous question. Which previous question? All questions are of similar pattern. You go through all the steps again. We have only learned this one method today. I needed to cover one more thing actually, but till now we have done this part. LRDI से डर लग रहा है, क्वांट हो जाएगा. डरने की कोई बात नहीं है. Don't fear when I am here. I have time material. Can I practice it along with practice questions of I-Quanta? At least practice the I-Quanta material. Whatever, see, fix one material, solve it thoroughly. And if you have done that, then after that there is no limit. Be it time, be it whatever, launchpad, समय, जो भी. Previous question can be done using Euler's. Yes. Euler's, I told you, one student was asking what if power is less. So Euler theorem we are making use only when the given power is quite higher than the Euler number. If it is less than Euler's number, then it is not going to help anyhow. I'm feeling unconfident because I'm not from math background. Leave this from your brain. Whether you are from math background or not, you should have brain. Use that brain. Don't be bothered by this thing whether you had math or not. If you didn't have maths, you are not from math background, that is advantageous in CAT, you get special points, extra points for that. 37/49 वाले का आंसर क्या आया था? 37 ही आंसर आया था, I guess. इसका आंसर 61 होना चाहिए भैया। 61 को आप 9 से डिवाइड कीजिएगा तो रिमाइंडर 61 नहीं ना आएगा, रिमाइंडर विल बी 7. When you divide 61 by 9, remainder is 7. रट्टा नहीं मारना है. Okay, I think that's enough. Thank you. So I will close this live session now. Goodbye. Yes, you can share your feedback here. Please answer this question now.